The focus of this video lesson is accident investigation data. We're going to be specifically looking today at something called the skid speed formula. The skid speed formula will allow investigators to determine the approximate speed a vehicle was traveling at the time the brakes were hit. So imagine this, a car is moving at a specific speed, they see an object in the road, therefore they slam on their brakes, and the tires of the vehicle make friction with the road itself, leaving skid marks. Based off of the distance of these skid marks and a few other factors, we can determine how fast this vehicle was moving. All right, so let's get a little more specific. So in our skid speed formula, S is equal to the square root of 30 times D times F times N, where S represents the speed the car was going, D represents the skid distance, or how long the skid marks were, F, the drag factor, which is based on the type of road surface. And if you look in the drag factor, we have different range depending on whether we have cement road, asphalt, gravel, snow, or ice. And then N is our braking efficiency. And this ranges between 0% if there are no brakes at all to 100% if the brakes are in excellent condition. So let's take a look at an example. Example 1. A car is traveling on an asphalt road with a drag factor of 0.78. The speed limit on this portion of the road is 35 miles per hour. The driver just had his car in the shop, and the mechanic informed him that his brakes were performing at 100% efficiency. The driver must make an emergency stop when he sees an obstruction in the road ahead of him. His car leaves 4 distinct skid marks, each 80 feet in length. What is the minimum speed the car was traveling when it entered the skid? Round your answer to the nearest tenth. And then, was the driver exceeding the speed limit when entering the skid? A couple of things to note. If there are 4 marks of equal length, then that amount is used. But if the lengths are different, or are there fewer than 4 skid marks, then the average of those lengths is used in the formula. If there's only 1 skid mark, then that length is used. Now, do note that the formulas used today are often presented in court and are recognized for their strength in modeling real-world automobile accidents. So let's take a look at what we have. So we do have 4 distinct marks, and they're all the same length, so we'll be using that 80 in our calculation. We know our formula is S is equal to the square root of 30 times D times F times N. We know that D represents the distance of those skid marks, so we know that is 80. We know that F represents our drag factor, so that in this case is 0.78. And we know that N represents our braking efficiency, and that is 100% or 1. So we're going to go ahead and plug in the information. So we have S is equal to the square root of 30 times 80 times 0.78 times 1. Using our calculator, we have 30 times 80 times 0.78 times 1. So we have 1,872 under the radical sign. Now, using our calculator, we'll take the square root of 1,872, which gives us approximately 43.26 or 43.3. So the car was traveling approximately 43.3 miles per hour. The speed limit here was 35 miles per hour. Therefore, the driver was exceeding the speed limit and could be fined. Now it's your turn to try. Try this. A portion of the road has a drag factor of X. A car with a Y% braking efficiency is approaching a traffic jam ahead, causing the driver to apply the brakes for an immediate stop. The car leaves 4 distinct skid marks of Z feet each. Write an expression for determining the minimum speed of a car when entering the skid. Example 2. Melissa was traveling 50 miles per hour on a concrete road with a drag factor of 1.2. Her brakes were working at a 90% efficiency. To the nearest tenth of a foot, what would you expect the average length of the skid marks to be if she applied her brakes in order to come to a full stop? All right, so remember, we know that S is equal to the square root of 30 times D times F times N, where S is the skid distance, S is our speed, D is our skid distance, F is our drag factor, and N is our braking efficiency. So what do we know? Well, we know her speed, so we know S. We know the drag factor, so we know F is 1.2, and we know the braking efficiency, N, and we know it's 0.9. So plugging in everything we know, we have that 50 is equal to the square root of 30 times D times 1.2 times 0.9. The first thing we're going to do is simplify the part under the radical sign. So simplify the radicand. We're going to multiply 30, 1.2, and 0.9. And we get 32.4 under the radical sign. So 50 is equal to the square root of 32.4D. Now remember, when solving equations, we always reverse PEMDAS. So in this case, we want to get D by itself. We ask ourselves, is there any addition or subtraction? No. Is there any multiplication or division? Yes, but it's under the radical sign, so we have to deal with that first. Are there any exponents? Yes. Mathematically speaking, just so you review from Algebra 1, anytime we take the square root, that is equivalent to a 1/2 power. You write that a little neater. So that's the same thing as putting something to the 1/2 power. Therefore, this is an exponent. In order to get rid of this square root, we're going to do the opposite, which is square. So we'll square both sides. The square root and square are opposites, so they cancel each other out on the right-hand side. On the left, we have 50 squared, which is 2,500. Now, we want to deal with the 32.4D. The 32.4 is being multiplied to the D. The opposite of multiply is divide. So we'll divide both sides of this equation by 32.4. 2,500 divided by 32.4 gives us 77.2 D. So we would expect that if she applied her brakes going 50 miles per hour, that her skid marks would be approximately 77.2 feet. Now it's your turn to try. Try this. Neil is traveling on a road at m miles per hour when he slams his foot on the brake pedal in order to avoid hitting a car up ahead. He is traveling on a gravel road with a drag factor of A, and his brakes are operating at 100% efficiency. His car leaves 3 skid marks of lengths X, Y, and Z respectively. Write an algebraic expression that represents the drag factor A.